look at all the unitary controllers, the floor level controllers, zone level controllers, the smart thermostats, and so forth, you're in the range of 20,000 different devices, CPUs.
Welcome everyone to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of today's show. Andrew, how's it going?
It's going very well. Thank you, Nate. Our guest today is Barry Coflan. Barry is a strategy consultant at Tower Hill Analytics, and he's going to be talking to us about building automation. His topic is 20,000 CPUs in the average skyscraper.
All right, here's you and Barry.
Hello, Barry. Before we start, can you tell me a little about yourself?
Hi, Andrew. Yes, I've been in the controls industry for a little more than 30 years. I spent the first half of my career in industrial controls and the second half of my career in building automation. I spent quite a bit of time at Schneider Electric and was responsible for a good bit of time for the development of the Schneider Electric building management system.
What does modern building automation look like?
Building automation today is fairly sophisticated. It consists of server at the top, usually on the local enterprise network, on a VLAN, and below the server there are floor level or zone level supervisory network controllers sitting on Ethernet, connecting back to the host server. Below those zone controllers are what are called unitary controllers, and those unitary controllers may be on Ethernet, but more likely they're on RS-45 networks over BACnet, which is a network standard in the industry, or a LAN network, similar to Modbus, but it's a protocol that is really used a lot in the building automation space. And those unitary controllers are spread throughout a building. They're connected to fans and heat pumps and all different types of HVAC equipment in the building. And then, of course, there's things like thermostats and sensors and so forth. And more these days, those devices as well, the sensors, smart sensors, will have a CPU and maybe a small operating system and a fair amount of software in them to make them intelligent and networkable.
And in the title of the episode, we're talking about 20,000 CPUs. Which of these is 20,000?
It would be the combined, of course. There's maybe one or two central servers, let's say. And when we're speaking of a skyscraper, we're saying something that's 60 floors and above, up to maybe 80, 100 stories in the very, very largest buildings. But something in the 60-story range would be considered a skyscraper, I believe. So all combined, when you look at all the unitary controllers, the floor level controllers, zone level controllers, the smart thermostats, and so forth, you're in the range of 20,000 different devices, CPUs. And the movement really has been to more and more intelligence. There's a movement in the industry towards smart buildings, and the proliferation of CPUs and small operating systems, as well as many of these devices have the ability to serve up web pages. So they have a small web server. Oftentimes they're running Linux or some Linux variant or some microkernel operating system.
So what struck me there is the 20,000 CPUs. I mean, to me, that's a lot of CPUs. I'm used to power plants and refineries in a portion of a refinery. One DCS, one control system's worth in a refinery. You might have 50,000 sensors. In a generating unit in a power plant, you might have between 20 and 50,000 sensors. Not each of them has a CPU, though. You tend to group a couple of hundred sensors onto a PLC. So you're dealing with a much smaller number of CPUs. But so I was surprised by all those CPUs. maybe I shouldn't have been. The modern world is all about more CPUs. CPUs keep getting cheaper. People keep building more of them into everything. I mean, a modern car has 200 CPUs, but still 20,000 CPUs seems like an awful lot of stuff to manage.
Yeah, that stood out to me too, but it occurs to me as I'm listening to Barry that we also did a building automation episode a few episodes back. Is Barry in the same sort of category as Fred Gordy, or are they coming at it from different places, or what?
Good question. Fred was with Intelligent Buildings, and Intelligent Buildings, installs, maintains building automation systems. They are a service provider, an engineering firm. Barry's background is product development. I mean, he worked in Schneider Electric. He worked with their engineers who deploy and manage automation in buildings as well, but he was also in charge of their product development. So the perspective he's giving us here is much more sort of technology centric than sort of the building gestalt centric that Fred gave us. The other thing that Barry mentioned that is going to come up in a second here is RS-485. And for anyone not familiar with that, this is a communications hardware standard. It's a signaling standard. A lot of us might remember, think 20 years ago, RS-232. If you wanted to get on the internet, you had to have a modem connected to your phone line and the modem connected to the computer with an RS-232 cable. RS-485 is like RS-232. It's a physical cable, but RS-232 you could only run about 8 meters, about 25 feet, and then it kind of petered out. RS-485 is designed for up to I think a couple of kilometers. At very close distances, you can do 10 megabits per second. At very long distances, it gets much slower. You can have multiple devices connected to the same cable. So it's a fairly old, but still very commonly used communications hardware when you're talking to physical devices. You're talking about Linux. Any Linux box can run a web server. But you're also talking about RS-485. Are you talking about a web interface over the RS-485?
Sometimes yes, in fact, because the occupants in the building will also have a mobile app that will connect from the thermostat to their smartphone so that when they come into a conference room or their office, they can set up their temperature preferences and their schedule and so forth will sync to their smartphone. So that's a local connection to that web server in that smart device. That smart device, that thermostat, may be connected with a Wi-Fi connection back to the server or some other upper level controller, or it could be RS-485, it could be Ethernet, it could be Zigbee. So there's a lot of different ways to connect those thermostats back northbound in the control system hierarchy. But again, they're often now starting to connect to the user via apps.
If you've got a smart thermostat with a web interface and it's running 485, you can't run a web interface over 485.
It would have Wi-Fi too. So the Wi-Fi, or it would have Bluetooth or Wi-Fi, and so. And often it's Bluetooth, so you can run a small web server and transact traffic via the app through Bluetooth. And if it's not a full web server like Apache or something like that, it's in a sense acting like a server, not necessarily a web server. But some of them do indeed have Wi-Fi and web servers. So it's a little bit of a mixed fare, and it depends on the capabilities of the thermostat. But these are fairly commonplace now. So the point is that there is a fairly easy access point from a cell phone or a tablet device right into a smart thermostat. And that thermostat may be backhauled northbound through RS-485 or Wi-Fi or Ethernet.
Andrew, not to complain here, but this 485 stuff seems a little bit wonky for this early in the episode. Usually we warm up to this stuff. What's so important about what you guys are talking about there?
Good call. it's all about connectivity. I always want to try and understand the connectivity, how the different pieces are connected, because whenever two CPUs are connected, whenever two computers are connected, it's possible for attacks to jump from one computer to the other. It's possible. They call it pivoting. You can attack one computer and use the compromised computer to attack the next connected computer. And, there's a lot of attack technology out there for, complicated systems like web servers and Linux. There's a much smaller set of, common attacks for things like RS-485 because it's such a primitive signaling interface. There's so little you do with it. And so I was just trying to figure out where it all fits, because if we understand how things are connected, we can understand how attacks can move through the system. And the point that I heard Barry make was that you don't do a web server over RS-485. That makes no sense. What he's saying is that, one of these smart thermostats might have a Wi-Fi connection to the cell phones in the room, or a Bluetooth connection to the cell phones in the room, or an Ethernet connection into the higher level controllers, or an RS-485 connection into the higher level controllers. But you would have the web server over the Wi-Fi, not over the RS-485. So that's the piece that was confusing me. Another question here. We've been talking mostly about environmental control, about HVAC. A skyscraper is also going to have elevators, and if we're thinking about sort of the most sensitive systems first, that's a safety critical system, is it not? Is this not part of the cyber equation here?
Well, certainly it would be, could be. And sometimes the elevator systems are integrated with the building management system or the security system in the building. So yes, those are certainly critical systems. And there are other systems, such as smoke evacuation systems in the event of fire, or fire control, fire suppression systems would also be considered mission critical.
Let's talk about cybersecurity. Let's maybe start with consequences. What consequences are we trying to avoid? If someone hacks into a building management system where the elevators are integrated, can they cause the elevators to plummet to the floor 60 stories and kill everybody inside?
I think it's probably a little bit extreme. Elevators, I'm not a deep expert on elevators, but from what I understand of elevator systems, they tend to have mechanical fail-safe built in the event of a control problem or a electrical problem, hydraulic problem, and so forth. So I think that's highly unlikely. But certainly, people could become stranded in an elevator for a long period of time, say sitting between floors or something like that, and that would not be great during a rush hour or so forth. So I think the odds of a catastrophic accident being induced is slim. Very slim, but certainly some other major inconvenience or safety issues.
Okay, well, as a user of elevators, I'm delighted to hear that there's mechanical safeties, and I'm not relying on a computer for my life.
Yeah, no, that's true.
So we've talked about denial of service if an elevator is stopped. Can you talk about the HVAC system? What consequences are we trying to avoid there? Is it just trying to avoid some hacker coming in and making it too cold for comfort, or what is the consequence that we're working on?
So I think if you're just looking at it from that perspective, like what sort of havoc could be wreaked on an HVAC system, it really depends on the building. Clearly in a hospital, a healthcare setting, where it's imperative to maintain positive air pressure in an environment where infection control is important. You wouldn't want anything to happen there while patients are being serviced or under care, and so that's sort of an extreme case where somebody could impact the airflow and potentially affect the health of the patient. So I think those are risks, and there's probably other risks that are more like Mission Impossible scenarios. That are extreme, but I think more of the question is around having this many devices on a network, having a very, very large surface area, the devices becoming smarter and more capable with more memory and more features, more connectivity, like we discussed with the smart thermostats now connecting to user apps. So fairly open to the public. to gain access to. And so I think it's a question of surface area. And then now you've got 20,000 computers at your disposal that you could use to mount other attacks within the in the enterprise. And I think that's probably the bigger concern, is just think of these as the potential for to act as honeypots, where it would be quite easy to sneak exfiltration routines in there to go and maybe go look for credit card information or other corporate trade secrets that you're trying to exfiltrate, and using these this very large surface area, these devices to act as sort of spy units in the enterprise. That's probably the biggest concern.
What I took away there, what I'm thinking about here is the backdoor. What Barry's talking about, he used the term surface area. I think he meant attack surface. An attack surface is the sum of all opportunities for attacking a specific target. And, 20,000 CPUs in a skyscraper, that's a lot of opportunities, especially if all of them have connectivity for Wi-Fi and Bluetooth and ways for sort of modern attacks to work their way into the system. It's not really an industrial concern, but a lot of businesses are worried about stealing data. And the industrial connection here is, imagine we have a 100-story skyscraper. We've got, 50 companies in the skyscraper, and there's a Tim Hortons on the ground floor. And, I walk up to the Tim Hortons, and it's got thermostats. It's got, a couple dozen of these CPUs hanging around. I connect to one of them. I discover that it's old. It has vulnerabilities. I hack into it. Now I'm in the building control system. I work my way into the floors with the targets that I'm interested in. I reach back out. You compromise CPUs one after another in sort of a chain your way into, the thermostat in the meeting room, and, start testing the connectivity with laptops and, other computers on that floor in that meeting room. And now I've got an opportunity to steal data from my target without even going through the internet. A lot of people imagine if I want to break into company X, I've got to go out to the internet and come in through sort of the front door and try and break in to the company through their heavily defended internet interface. This is a backdoor. It completely bypasses the internet. If they discover that the information's gone missing, where did it go? Well, let's look at the records. It never went out to the internet. It disappeared mysteriously. How did, it's the industrial connection is that we're using the industrial systems as a vector, as a way to do these other more sophisticated attacks.
I get what you're saying, but as you describe that scenario, it reminds me of a thought that I had at the beginning of the episode when, he's describing 20,000 CPUs in this giant skyscraper. I sort of get the industrial connection, but it seems to me like we're talking a little bit more about IoT. Am I wrong?
There is some of that. And, Barry uses that term from time to time. What is IoT? What is industrial IoT? I think about the two differently. I think about, what is industrial IoT in terms of two characteristics, capability and context. If a device is capable of controlling the physical world, to me, it's a candidate for industrial IoT. A lot of IoT in the world is measuring, my heartbeat, is measuring things in the world. But if we're controlling the world, now it's a step, it's 6 steps closer to industrial in my books. And then the other one is context. Is it in an industrial context? Well, if I'm doing control capable IoT in a refinery, that's industrial IoT. Is building automation industrial? Well, kind of. It's sort of on the edge of industrial. Most people will look at it and say, heavy industry is obviously refining and automobile manufacturing. But things like building automation and even the automation that's in automobiles, not the automation for building the cars, but that's in the cars, that's sort of on the edge of the industrial space. But people generally still use the word industrial for that, yes.
Okay, so you mentioned context and capability, but what about consequences? Because it occurs to me that you mentioned this scenario of the elevator falling 60 stories, and Barry mentioned that that's a little bit far-fetched for what we're talking about here, and then the hypothetical you just gave me largely surrounded stealing data. This sounds a little bit more like the kind of consequence you get in IoT or the IT space rather than with industrial systems. Are there consequences to what we're talking about that mirror the kinds of consequences that we usually deal with in the industrial space, whether it's, chemicals blowing up or whatever it may be that we usually cover on this show?
That's a very good point. Maybe I need to change my categorization for industrial. I like what you said. You just said the consequence. If it's a physical industrial consequence, then it's an industrial system. If the physical consequence is frozen elevators, or as Fred Gordy described a cavitating chiller that's been destroyed and needs months of repair, that's a physical consequence. If the consequences are only business consequences, like stolen information or lawsuits or stuff like this, to me that's an enterprise consequence. And the scenario I gave you was an enterprise consequence, stealing proprietary data, credit card numbers, who knows what. But it was stealing them via an industrial system, because if you compromise the industrial system, yes, you've got an opportunity to get into the enterprise as a backdoor, but you've also got the opportunity to cavitate your chiller or to lock up your elevators or bring about physical consequences. So I maintain it's an industrial system. I like your categorization. But you're using the industrial system in my scenario, in what I heard Barry talking about, as an attack path into the enterprise. You mentioned two protocols, BACnet and IoT. Is that IoT Internet of Things or IoT something else, or did I get it wrong?
Yeah, the IoT is more of an architectural construct of Internet of Things, which is, you've got these smart sensors now in smart devices that you put into a building. They're not connected in the building on the VLAN necessarily to the BMS directly. It's going out over the cloud itself. It has its own cloud connection as a device, and then the data is going up to the cloud, and then it's being relayed back down into the BMS. So if you want to pick up a remote temperature or a lighting sensor or some device like that, rather than hardwire it to the BMS, they'll actually bring it up over the internet and push the data back down into the BMS. The protocols in that case, the protocols are varied. They tend to be IoT protocols like MQTT or other IoT type protocols. They're not necessarily BACnet in that case. They're IoT type protocols.
Okay, so the internet connection is often where people's imagination for security starts. You're saying the modern IoT device reaches straight out to the internet, presumably over the cell network or something, or maybe local Wi-Fi.
Sure. Yep.
The application server is connected into the enterprise network and through the enterprise into the internet, but none of the other servers are directly connecting to the internet. They all connect to the application server, and they don't go straight out.
They connect to the central server. They're capable of going out, but typically they're as an installation best practice, they're isolated on the VLAN. However, the central server is usually connected to the internet, so that you can do this remote servicing of the building.
Okay, and when you say connected to the internet, it is accessible from the internet. It's actually connected to the enterprise network, which is connected to the firewall, which is connected.
That's the better way to look at it, yes. Now, I did slip in something a little bit insidious there that we kind of bypassed. And what I said was that those floor level or zone level controllers, they are capable of connecting to the internet. And this is a real concern, because they have full-blown Linux operating system, Apache server, that kind of thing. And, ideally they're behind the firewall on a VLAN and so forth, and isolated and air-gapped, if you will. But in reality, we know in the industry that Unfortunately, best practice installation isn't always done. There's many system integrators in the world, thousands of them, that are installing these systems around the world. And we know that they're installing them with default passwords and the like coming from the vendor. It's not funny. It's actually very serious. And they'll use the default IP address. They'll use the default passwords. They will put these embedded Linux controllers not necessarily behind the firewall. They will put them on the internet and not even know they're doing it. So this is a serious problem, and this is existing in the industry today.
Waterfall Security Solutions is the OT security company. Waterfall's new ebook describes advanced unidirectional security for power generation. Now, many of us are already aware of basic unidirectional protection for power plants. After all, 1/3 of all North American power production is already protected unidirectionally. The new ebook explores 5 advanced applications of unidirectional gateways for power plants. You can find the ebook at the Waterfall website. Look for ebooks in the resources menu.
The last thing that Barry said here is, to me, actually a little distressing. He's right. Linux is Linux. Linux is a programmer's paradise. I love Linux. I'm a programmer. I'm a hacker at heart. You can build anything on Linux. Most people have. You can download stuff for Linux. Linux is, the engine of the modern internet. Most of the internet's web servers are running Linux. And what he's saying is you got 20,000 CPUs, most of which are Linux, in one of these buildings. Every one of them could reach out to the internet. Every one of them could be a full-fledged citizen on the internet. Best practice is that they should all connect to the application server, and the application server is the only interface to the enterprise network or to the internet. Presumably we would defend that application server, instrument it fairly heavily. But if someone did not use best practice and connected 1 or a dozen or 50 of these other Linux, 20,000 Linux devices out to the internet somehow, how would we notice? I mean, that's it. It speaks to another huge opportunity for backdoors. I mean, Shodan, that we talked about a couple of episodes ago, might be able to find some of the stuff if it was listening, if these Linux boxes were listening on certain ports. But, if they were just reaching out and doing stuff on the internet, how would we even see that? I mean, you're trying to find a needle in a 20,000 CPU haystack. Very distressing to me. You talked about attack surface. The other piece of the attack surface is, networks throughout the building, devices throughout the building. How bad is this? How easily accessible are these devices for tampering?
Well, normally they're physically locked in a closet, and they're in an electrical panel, like a control panel, which may or may not have a key lock. And so they could be in like a janitor's closet, for example. They can be embedded. They can be up in the ceiling, behind ceiling tiles. Oftentimes, remember, there's 20,000 of these things, so you're trying to hide them in every nook and cranny you can during construction. And so, it's more security by obscurity, I would say, than it is, a very stringent locking down and physically locking everything. But in best case, you've got a physically locked closet, like an equipment closet, and a locked panel. And ideally, you have a security camera in that closet, so you know who's accessing it. You've got a badge system, so you know who's badging into the closet, and so forth. So from a physical standpoint, you're kind of trying to limit the access. But when you get up into the ceilings and so forth, it's nearly impossible to limit access. These devices are spread all over the place, and it's tough. And then when you start getting into these things like smart thermostats that we talked about, you've got a Bluetooth connector there, and if your enterprise has given you access to download the app, now you've got connection to that thermostat with your app. And it's over Bluetooth. It's theoretical that somebody could get a sniffer on that reverse engineer that protocol and possibly hijack that thing. There's a lot of avenues for entry, mainly because so many protocols, really huge physical challenge if you were going to put everything under lock and key. And there's a lot of ports, physical ports, USB ports, Ethernet ports, Bluetooth, Wi-Fi, et cetera, that these controllers are featuring. And so it's a problem.
So these are all serious problems. You talked about the difference between older systems and newer systems. Are there solutions out there? Is this getting better?
I think it's getting better slowly. I think there's awareness growing. Some of the major trade organizations are starting to focus more on this. ASHRAE, for example, which is one of the major trade organization focused on heating, ventilation, and air conditioning. They have a new section that's focused on this. NEMA is now focusing more on cybersecurity in the enterprise, including in building management systems. So I think the industry is starting to get better. And as well, there's some standards like 62443, which were originally designed or aimed at SCADA, industrial SCADA systems and PLCs, but are broadly applicable to the building management systems. And those are starting to become adopted by the major vendors of building management systems. And that, I think, is gradually getting its way out into the customer base. But we have a long way to go. There's millions upon millions of buildings out there, and I would say the industry is in its very early stages of getting a kind of systematic grip on this.
So you mentioned 62443. I mean, in some industries they're adopting 62443 because really they have nothing of their own, and so that's what they see out there. Is 62443 really a good fit for building automation?
Generally, yes, up to, I would say, security level 3. Once you get into security level 4, then you're starting to look at very, very stringent, very customized mitigation and defensive strategies. But up until level 3, I think with proper planning and discipline, that should be fairly attainable in most buildings, with some care and a little bit of investment. So I think overall the model fits well. It's not perfect. There's a handful of things I need to be treated a little bit differently in the building management system world than in the industrial world. But by and large, it fits. There's also the NIST standards, which I mentioned ASHRAE earlier. But I tend to lean more towards the 62443 versus the U.S. standard because it's international. And building management systems tend to be, developed and marketed as an international global product. So the manufacturers, it's very difficult for the manufacturers to adopt and support every single standard. It's too expensive, and sometimes the standards can run a little bit counter to one another. So I'm more of a believer, and I think most of the manufacturers you would find of building management systems are gravitating since 62443 because it is global in nature, and that way they don't have to necessarily deal with every single local country level standard. And again, there is a fair amount of overlap between them anyway. There's some differences, but by and large, I think you're getting most of what you need there.
For older buildings, for older systems, what are the options there? How do you protect them?
It's tough. It's really tough. So realize that when we mention that number of controllers, 20, 30,000 controllers, even in some cases, these controllers are built into walls. They're plastered in some cases. It's not like a removable ceiling. I mean, they're very, very difficult to remove and upgrade. And a life cycle of a building management system can be 20, 30, 40 years even. And so trying to rip and replace and put in a new modern system is not trivial. what a lot of vendors are doing now is it allows you to rip out the main server and kind of encapsulate the older system, and wrapper the older system with a newer, more modern system, which would definitely be more secure. So there are some things you can do to sort of protect yourself, but in a lot of cases, there would be no substitute for rip and replace if you can do it. It's just not always feasible. The one thing I would add to that is, I do think there are some great, kind of newer, modern network surveillance tools, passive and active tools that are coming onto the market that different companies are investing in and developing, that are helping monitor traffic on the older systems, so that at least if you can't fully protect it, you can detect more quickly if there's a problem. And I think of like Industrial Defender and maybe Cisco and a few others that are investing and doing some good work there to try to secure not only the modern system, but also to help detect problems with the legacy installed base to ensure that you catch something quickly if it goes awry.
Again, there, Barry had brought up how these CPUs are in janitors' closets and behind these plaster walls and ceilings. It occurred to me earlier, but I didn't ask it. Are these devices, or these connected systems in these strange locations by virtue of, saving space in the building, sort of like what we were talking about in our recent episode about trains, how there's only a certain amount of space to put computers, and so you sort of have to mush it all together? Is it for that reason that these machines are where they are, or are they specifically hidden in like ceilings and closets? The phrase I believe Barry used earlier was security by obscurity.
That's a good question. I'm not certain of the answer. I know that, people are reluctant to dedicate floor space to these functions. So, closet space is a bit at a premium. It's sort of more convenient to stick things into the ceiling. I strongly suspect another factor is wiring. Even if an RS-485 cable can run 4 kilometers at a very low rate of data transfer, an Ethernet twisted pair cable can run, I think, 100 meters. Running cable is expensive. If you're running cable to 20,000 things, that's a lot of cable. And the longer it is, the more expensive it is, and the more expensive it is to install. So I think, and I didn't ask this question, but my guess is that it's a cost-saving thing. If you've got a lot of stuff coming together, it's less cable and less labor laying the cable if it's sitting locally in a ceiling than if it's sitting across a large building on the other side of the floor in a wiring closet. So I don't know that people are deliberately trying to hide stuff. They're trying to keep stuff out of sight because the tenants don't want to see this stuff. But I think, where they put things has more to do with cost savings than it has to do with security. And that might be something that has to change in the future. I don't know. I wanted to come back to an earlier topic, though. Barry mentioned the IEC 62443 standard. This is a very well-known standard in the industrial space. It's a family of standards. The ISA, the International Society for Automation, designs the standards. The International Electrotechnical Commission publishes the standards. And he talked about, that being sort of the best fit. There isn't a good sort of specific to building automation cybersecurity standard out there. But he talked about 62443 as being international. And I think this is where we're sensing a bit of his vendor perspective, because he represented a vendor for 15 years. The vendors would like to have international standards that they can build their systems to comply with, rather than a whole slew of local standards, because it's just less to understand. So what I'm taking away from this is that if down the road there becomes a cybersecurity standard that is designed for building automation, the vendors would really rather that standard have an international pedigree, an international drafting team behind it, so that, again, they don't have a different variation of it in every geography that they have to comply with. So let me explore that for a second. In the process industries where I do most of my work, power plants, pipelines, there are engineers deeply involved in the physical process in cybersecurity. A power plant will often have 2 or 3 engineers permanently stationed at the power plant. They come to work every day, 9 to 5. They're physically there every day, involved in the operation of the plant. Now, I understand that, the civil engineer who approved the building might not be there every day, but is there not, and my point is that these engineers have become aware of security and are becoming very involved in security. There is a civil engineering practice that's involved in large buildings. Are these engineers not involved in the security process at all?
It's not really civil engineers that put together the building automation system. It's usually a subcontractor to the mechanical engineer, who is in turn a subcontractor to the general contractor, who got some blueprints from a civil engineer. So to try to give you some perspective, there's a kind of flow down of responsibility through subcontractors. And but more to the point, there's in a large building like a skyscraper, there's absolutely a team of a few people, 3 to 6 people, depending on the size of the building, that are maintaining that skyscraper, pretty much 24 hours a day. And, they're worried about many things, and cybersecurity is one of them increasingly. But more of the case is like, you've got a 5-story hospital building that covers an acre or two, small, say 200, 300 bed hospital. And they'll have their facilities people as well, but they're looking after medical equipment and many, many other things. How worried they are about the cybersecurity of the building management system, I don't know. It's probably pretty far down on their list. And many buildings, like a 10-story office building, for example, it will have nobody on site. I mean, everything is managed remotely. And they have no engineer on site. It's completely running blind with a remote, some remote service contract where somebody, if there's a major alarm, they'll get the alarm. But day to day, there's no one there. And that's a big part of the stock of buildings, like 100,000 square foot building, a kind of 10-story office building. That's the sweet spot of the market. That's the majority of the market. I'd also say the ownership of maintaining that system, the cybersecurity in that environment, is not always clear. You have the building owner, and then you have the tenants of the building, and there could be a different tenant on each floor. So each tenant could have their own IT back at their headquarters, and then maintaining, some kind of cybersecurity vigilance. But they're all sharing the core physical network of that building through some VLAN, perhaps, and all the tenants. And then you've got the landlord, and hopefully the landlord's doing their part to secure that trunk line coming out of the building. So you have those scenarios taking place as well in a mixed tenancy type of environment. So ownership isn't as clear as it is in the industrial setting.
So Barry, thanks for that. We're coming up on the end of the episode. Is there a thought you'd like to leave with our listeners?
I think there's a few things. I think if you're a major tenant in a building, or you're an occupant of a building, you should be discussing with your IT and your landlord. You should have a discussion with them around cybersecurity. You should understand what the exposure is, what the risk is, what is being done to mitigate the risk, you really should just start by inventory. Just understand the situation that you're facing, and don't let it turn into a problem before you have to deal with it. You could very well find yourself out on the street with not being able to occupy the building if something catastrophic happened, and that would be very expensive and very disrupting. So I think it's very, very smart to just understand what you're facing to begin there. And then I think going from there, I would move into some type of passive monitoring, maybe some active monitoring, reporting, so that you're getting events from that BMS network, and you're bringing that into a flow so that you can be warned if there's some activity taking place as soon as possible. And then thirdly, I would say know who to call when something does start happening. Like, who are you going to call? What are you going to do? Have some type of reaction plan so that you're not wasting valuable time while this is happening, and so you can troubleshoot it quickly and mitigate as quickly as you can. Because I think a lot of times the stories that I read that an event will take place and it will be going on for a month or two before somebody finally does something about it, and that it can kind of go under the covers, if you will. So those are the three things. Find out ahead of time what you're dealing with, what your risk profile is. Get some monitoring in place. Like we mentioned earlier, there's some vendors now that are starting to work in this area. So get with those vendors, get monitoring in place, and then have an action plan if in the event you do have a problem. You know who to call and how to address it. So I'd start there. Beyond that, based on your inventory, you may have to take some serious action about ripping and replacing equipment in the extreme and upgrading. But I think you can start at least by knowing what you're facing before you do that.
Andrew, how about a last word from you?
Well, it sounds like we have our work cut out for us in the building automation space. I mean, the measures that Barry mentioned are a good start, but looking forward, it seems to me that we really do need specific advice and standards for building automation. The big thing that I take out of the interview with Barry is the exposure inside the building. I mean, if we have smart thermostats and smart light switches with, and each of them has Wi-Fi connections, and each of these devices has limited security because they really weren't designed for security. And if they've got a 40-year lifespan, who knows if they're going to be secure 40 years from now. If these devices have limited security and they're networked into similar devices elsewhere in the building, if anything in the building can be compromised from a coffee shop, and we can use the compromised devices to start looking around in the building for other similar devices on other floors and other tenants. Now we can launch attacks on any other tenant, looking for their Wi-Fi, stealing passwords with phishing emails. That's a kind of exposure that we don't see so much in power plants. There's not a coffee shop that I can drive up to and gain access to a network that's connected through a power plant that way, or a refinery. It seems to me this is a kind of risk that would be good to address in advice that's specific to the building automation sector.
Let's end things there then. Thanks to Barry Coflan for speaking with you, Andrew, and Andrew, thank you for speaking with me.
Always a pleasure, Nate. Thank you.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody listening.